All right, you guys, here for number 11, we have that Nicole, okay, works at a local school 5 days each week. Nice. She drives an old car that has a 72% probability of starting? Dude, I don't know if I would use a car like that, but whatever. Nicole's Nicole, everyone does their own thing. The probability of the car starting on a given morning is independent of it starting on any other morning. So what it is saying here, all right, probability of the car starting is independent of it starting on any other morning, is that if, for example, yesterday it did start, that doesn't mean that today it's more likely for it to start. Or if yesterday it didn't start, that doesn't mean that today it's more likely for it to not start. Okay? So it doesn't matter what happened yesterday, the probability will always be 72%. All right? So for part A, we need to find the probability that Nicole's car starts on exactly 3, so this is important information, in a particular 5-day work week. And so from here, I mean, I can just jump and show you what to do on the calculator right away, but I think it's important that we talk a little bit about your approach, how you think about the problem, etc. So some of you are probably thinking, okay, so there's a 72% probability of it starting. So 72% of start. That does not look like 72. So there's a 72% of start. So that means you have, 1 minus 0.72. That means I have a 0.28 of not start, right? And so 72% is the same as 0.72, right? And so from here, maybe some of you would think, okay, technically I can do a tree diagram, right? So this is start, this is not start. And up here, I'm going to have 0.72. And down here, I'm going to have 0.28, right? And you can do this for the 5 days. But you're going to notice that, okay, this is first day, this is second, this is third, this is fourth, this is fifth. Your tree diagram ends up being huge because you have to add this, 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 this. You have to add so many different things to this tree diagram that you end up with a lot of different probabilities. And calculating this is going to be a headache. It is going to be annoying, and there's definitely a faster way. But why am I pointing this out? I'm pointing this out because if you're thinking in a tree diagram, then what is behind the scenes is that you're thinking of A or B. What do I mean by this? It is heads or tails. It is only two options. So if you're thinking of only two options, which is a little bit like the tree diagram, right? It's either start or no start, start or no start. If you're thinking of only two options, then, well, only two has a root associated to it, right? Only two has bi associated to it. You have bisexual, you have by this, you have by that. And so technically here, ah, this guy is going to talk about binomials. This guy's going to talk about binomial distribution, all right? So point is, if you ever find yourself thinking of only two options, start or no start, rain or no rain, heads or tails, anything like that, okay? Go to them all or not go to them all, yeah, it's a binomial distribution, okay? And so I want to talk about this because it's the first step to realizing, I need to use the binomial distribution stuff on my calculator. Now, what does your calculator have? So because it's a distribution, you gotta hit that blue button here on top of vars. So you go to second, vars, and here are your distributions. Now, we're very used to using the normal distribution, right? And so the binomial one is way more down, which is here for letters A and B. Now you only have two tools, so that's good news. There's not too much we have to learn, right? And so here's the intuition I'm going to share with you. Binomial PDF versus binomial CDF. For PDF, it's just that amount, and for CDF, it's going to be from 0 to that amount, okay? It'll make a little bit more sense in just a second, see? So binomial PDF is just that amount, binomial CDF is from 0 to that amount. And so because PDF is just that amount, and here they ask for exactly 3 mornings, all right, I gotta use binomial PDF. So this is the first thing we can kind of identify. PDF is for an exact amount, right? So maybe I'm gonna write exact, and CDF is from 0 to that amount. So maybe you're thinking of at least, stuff like that. Okay. All right. So as long as you associate PDF to an exact amount or just that amount, you'll be fine. Now, so at this point, you're probably taking the test. You identified its binomial PDF. You're looking at exactly 3. So you're going to open up your calculator and press binomial PDF. And from here, oops, I gave away a little bit what we have to put. My bad. But point is, from here, you're going to see, okay, it has trials, it has p-value, it has x-value. There's definitely a couple things we have to fill in. What is what, right? So trials, think about it this. Trials is sort of like the amount of times you're going to be throwing the coin, okay? Trials is the amount of times you're throwing the coin. P is the probability that, the head lands heads. I mean, sorry, the coin lands heads, okay? Or in this case, it's going to be the probability of it starting, right? And then the x value is how many times you want it to successfully have started. All right, so let me explain that one more time because it's super important. So for part A, we're going to be using binomial PDF because we have exactly 3 mornings, okay? And so from here, we need to fill in trials, we need to fill in a p-value, and we need to fill in an x-value, okay? So for trials, it's actually, let's start from below. I think from below makes a little more sense. So your x value is how many times you want your event to happen, okay? So if it's at exactly 3 mornings, then exactly 3 times I need my car to start. Now, this p is the probability of it starting, right? Why are we looking for the probability of it starting? Because here it says, find the probability that Nicole's car starts. Okay, so probability of it starting, we said earlier 72%. So that is why this p, which is just probability. Okay, so this p is going to be 0.72 because 0.72 is 72%. All right. And now for trials, think about it this way. It's okay, you want it to start 3 times out of how many days? So 5 days because it's a 5-day work week, right? And so trials will be 5 because there's 5 days in a work week. The probability of it happening is 72%, and you want to happen exactly 3 times. So you put an x value of 3. So you put all of this into your calculator. So trials 5 because it's a 5-day work week. 0.72 for probability of it starting. X value of 3. It happens exactly 3 times. Exactly. So we're using PDF. You paste. Enter, enter, there it is. So the probability for part A is going to be 0.292626. All right? Yes, and if you consider significant figures, you would count 1, 2, 3. Do you round it up or keep it the same? You round it up. So significant figures, you can leave it as 2.93. If you want, you can always leave your answer with the long form. I suggest doing the long form. Just forget about sig figs. Anyways, how would you show your work? You might be asking. You need to show evidence that you used the binomial distribution. And so technically, see how your calculator here, there's like this line up there. Okay, so this is evidence that you did what you did. Okay, so for your method point, you can literally write binomial PDF and that whole thing in parentheses. 5, 0.72, and 3. And so what this is saying, like just so we really understand, what this is saying is that you went to your calculator, you used the binomial PDF function, and for the first thing they asked, you put 5. For the second thing they asked, you put 0.72. And for the third thing they asked, you put 3, which is exactly what we wrote over here. Okay, so this is this. All right? So right now, you would get 1 method point over there. and one answer over here, okay? I know the thing of writing out the binomial PDF might seem a little bit ridiculous or tedious, but it does give you a method point, so do it. If you want to get really, 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 really fancy, you could express it like this, all right? Which is like the more hardcore mathy way. But for me, more intuitively, we used our calculator. Our calculator spit this out, and if you write that, it'll give you the method points. As long as there's evidence of using the binomial distribution, it's fine. All right. Anyways, that is for part A. Okay. Part B gets a little bit more exciting because we have the Nicole apparently walks to work on mornings when her car does not start and it's not raining. On the other hand, Nicole takes the bus to work on mornings when her car again does not start and it is raining. And so what's the difference? If it rains, if it rains, she takes bus. If it doesn't rain, she walks. That simple. Not rain walk, rain bus. If her car doesn't start. If her car does start, she takes her car. Why would you not, right? So, then they tell us, in respects to rain, that where Nicole lives, there is a 42% probability of rain on any given morning, independent of any other morning. Whoops. Independent of any other morning. Now, we already talked about independent of any other morning. It means that if it rained yesterday, that does not change the probability of it raining today. If it did not rain yesterday, it does not change the probability of it raining today. Independent. This 42% is not going to change. Every day it'll be 42%. The probability of Nicole's car starting is independent of the water, so it doesn't matter if it rains or not. Nicole's car probability of it starting does not change either. All right, this is a pretty standard assumption. Probabilities are not going to change. Now, for part B, this is where it gets juicy. We have find the probability that Nicole will not have to take the bus in a particular work week. And so now we have to start thinking, okay, what are the scenarios where she does take the bus? What are the scenarios where she doesn't take the bus? What are the scenarios where she takes the car? What are the scenarios where she doesn't take the car? And from here, actually a tree diagram helps. So we talked a little bit about how a tree diagram helps a lot for like one thing happening or the other thing not happening, right? And so I filled it up with car starting, not starting, car starting, not starting. But you can also use a tree diagram for two independent events, okay? For example, you can also do a tree diagram for like, I don't know, heads or tails, and then whatever, like even number on a dice, okay? Or odd number on dice, okay? And so, yes, here you have a coin and here you have a dice. That's fine, okay? You can have that on your tree diagram, okay? That's legal. You can do it, and there are exercises on the B that have stuff like that, okay? Point is, I'm going to draw a tree diagram to better understand one day. So this is going to be just for one day, right? I'm not going to do the 5-day work week because it would be a crazy tree diagram, okay? A 5-day work week would be an insane tree diagram that we want to avoid, but this can help you find probabilities for one day, all right? So a tree diagram for one day would look something like this. For our good old friend Nicole, we have either the car start or the car no start, okay? So the car starts or no starts, right? So if the car starts, she's gonna go on car, and the probability of this is 72%. So here I'm gonna put 72%. And no start means no car, which is 28%. All right, so if her car starts, she's just gonna go on the car. So your tree diagram is gonna reach there. See, you don't care from here if it rains or not, because she's going on her car. So whatever, right? Now, if it doesn't start, if it doesn't start, there's a difference between walking if it doesn't rain and bust if it does rain. Okay? So from here, I'm going to put rain, which we know is 42% probability. So if it's no start, then it's rain, which is this here. Oh, sorry. No start and rain. So no start and rain is this, right? No start and rain, bus. So no start and rain, bus. What's the probability of this? 42% probability of rain, right? 42% probability for rain, right? Notice how here the 42% is associated to rain, okay? And for example, this 72% is associated to start, okay? The probability of taking the bus has to do with this scenario here. It's like taking that path. And so it's not that the probability of bus is 42%, it's that the probability of rain is 42%, okay? I'm going to talk in a moment now how to get probability of going on bus, not going on bus, stuff like that. See? Just thought I'd point that out for a second. Don't get lost in the sauce. 42% is probability of rain. Okay, we have not yet found probability of taking the bus. And so we have rain or no rain. Rain, no rain. And the probability of no rain is 58%. Because if the probability of rain is 42, right? That means I can do 1 minus 0.42. This gives me 0.58. So probability of no rain is going to be 58%. So if it's no start, so no car, and no rain, no start, no rain, walks. So here I'm going to put walks. All right? All right. And so from here, for one day, I can try to calculate the probability that Nicole will not have to take the bus to work, right? Now, this is very important that you think about probability the right way. So right now you're trying to find the probability that Nicole will not have to take the bus. So probability not have to take bus. For finding the probability of not having to take the bus, you first think of the scenarios where Nicole doesn't have to take the bus. And so what are the scenarios where Nicole doesn't have to take the bus just looking at this tree diagram? All right, take a moment, try to find them. What are the scenarios and how many where Nicole doesn't have to take the bus? Here we have two scenarios. You have this first one where the car starts and so she just goes, no bus, right? And you have a second scenario where it's okay, your car doesn't start, but it doesn't rain, so she walks. Those are your two scenarios, okay? And so from here, I'm gonna have scenario, green and scenario dark green. So I have scenario light green and scenario dark green. And from here, you gotta find the probability of both, right? So what's the probability of light green? Well, quite simply, it's just 0.72. So there, the car starts right away. It's 0.72. Yes, it's that simple. The scenario of dark green is a little bit different because to reach no walk, that means you pass through no rain and pass through no start. And so think about it this way. So scenario one is just car start. So car start is 0.72, right? Scenario 2, or dark green, is car no start, and that was a crazy voice crack, and no rain, okay? So notice how suddenly I put the word and in here. And in probability, you guys, and, whenever you find yourself saying and, you're going to be multiplying. And whenever you find yourself saying or, you're going to be adding. Yes, it is that straightforward. So notice how a lot about what I'm talking about here is how to think about probability. The numbers and the fractions you're putting into your calculator are really not that hard, but you do have to keep in mind if you're thinking in terms of or, it's plus. If you're thinking in terms of and, it's multiply. if you're thinking in terms of one or the other, it's binomial. Okay, that kind of stuff is what we need to identify. So scenario 2 is car no start and no rain. And so from here, because and is multiplied, probability of car no start is 0.28, right? It's this 0.28 that's here, times, because we have and, times for and, probability of walking, right? Probability of rain, 0.58, right? And so no start, 0.28, and means I multiply, no rain, 0.58. That is how I ended up with this, okay? And last but not least, the scenarios where Nicole doesn't have to take the bus is what we have in light green, and we have what we have in dark green, so 0.28 times 0.58. But now, the probability of not having to take the bus are the scenarios where Nicole doesn't have to take the bus. And the scenarios where Nicole doesn't have to take the bus is scenario light green or scenario dark green. Oh wow, will you look at that? So now we put in an or, and what was or? Or was add. So from here, or your last line of math, right, for one day, you will have 0.72, which is your first scenario, or these voice cracks are on a roll today. So 0.72 for your first scenario, or 0.28 times 0.58 for your second scenario, okay? And so you put all of that into your calculator and you find 0.72 plus 0.28 times 0.58. So this gives you 0.8824. 0.8824. Now we really need to understand something from here, okay? What did we just find? We just found the probability of not have to take the bus on one day. Okay, this tree diagram is just for one day. And this problem is worth 4 points. So it can't be that simple. Okay? Here they tell us to find the probability that Nicole will not have to take the bus in a particular work week. Okay? So we just found the probability of just one day, and now we need to sort of like extend that to the whole work week. So the probability of not one day, right? The probability of not having to take the bus in a whole particular work week means that we have Monday, no bus, and Tuesday, no bus, and Wednesday, no bus, and Thursday, no bus, and Friday, no bus. So you have a bunch of ands. You have Monday no bus, and Tuesday no bus, and Wednesday no bus, and Thursday no bus, and Friday no bus. And so from here you realize, okay, probability of Monday no bus, 0.8824, times Tuesday no bus, 0.8824, and Wednesday no bus times 0.8824, and so on and so forth. So what you end up with is 0.8824 times 0.8824 times 0.8824, and all of this will be happening 5 times. Why 5 times? Because we're talking about 5 days. Okay? So you can open up your calculator. You can put 0.8824, put it to the power of 5, and boom. This is Nicole not taking the bus 5 times. So probability that Nicole doesn't take the bus 5 times. Boom. There it is. So probability of Nicole not taking bus is 0. For part B, we end up with 0.53496. 3496. If you want to do significant figures, you can count 1, 2, 3. Do you round it up? I'll give you the same. You round it up. So 0.535. All right? Guys, this is one way to do it. It's what I think is most intuitive, especially because of this step here. And again, always try to think in and or ors, okay? The hardest part of statistics and probability is how you approach the problem, how you think about the problem. See? So I hope that thinking about one day and then taking it to a whole week helped. Okay? Now, if you want to stick to the calculator using the binomial distribution and all that stuff, okay, technically from here, from the 0.8824, you can take it to your binomial PDF or CDF over here. See? Now notice, because we're talking about the probability that Nicole will not have to take the bus, okay, that means she exactly of the 5 days of the week doesn't take the bus. So notice that exactly 5 times doesn't take bus. So exactly 5 times she doesn't take the bus. So you can go to the PDF once again, 5 trials, because we're talking about a whole work week, right? Our probability of not taking the bus is 0.8824, and our x value, which is the amount of times we want this to happen. So we want Nicole to not take the bus 5 times. Our x value is 5. Yes, trials is 5, x value is 5. 5-day work week, Nicole doesn't take the bus 5 times. Exactly 5 times. Boom, it's the same number. Okay? So now maybe you also learned a little bit what your calculator does behind the scenes. All right? This is, to my liking, the most intuitive way to approach this problem. Okay? I know there's another approach, which is instead of doing the light green scenario and the dark green scenario, you just find the probability of this. Okay? And so you do everything thinking like not, right? So you would do 1 minus what you get there, and then you put that into the calculator and stuff like that. See? Um, for me, it's more intuitive if I talk about the two scenarios, the light green, the dark green. But I'm just saying, once you look at the answer key, you're gonna see that there's more than one way to do this. See? So this right here is what I told you guys, right? So here you're finding the probability of taking the bus, right? There you have the probability of taking the bus, and you work backwards from there. That's why it's also 1 minus this. See? In fact, 1 minus that is going to give you the probability of not taking the bus. Okay? So you can work backwards. Maybe it's more intuitive. I'm just pointing it out in case it helps you. Okay? For me, it's way easier if I think about only the scenarios of not taking the bus and work from there. Okay? But, yo, to each their own. All right? I hope it helped. And that is number 11.